the goal of this lesson today is to be able to take the antiderivative of something like this fraction. Okay, and as of right now, we cannot find this antiderivative. You could try u substitution, but you'd end up with x's and u's, which won't help you. Antiderivatives by parts you could try, it's not going to help you as well. Okay, so we need another technique. Here's the key to this lesson, and it goes back to kind of algebra 2 stuff. Question.
How does it go on class 50? Sometime online.
Yeah, our lessons, of course, I have videos online, so you can watch the videos of the lessons online if you were not here. And here is your project's rubric if you need it. Okay. The quiz for this lesson should only be 4 problems. Okay, not 6 to 10, and you will see why shortly. All right. Back in the day, you were asked to, simplify maybe this, adding 2 fractions together, and you were asked to, combine these 2 fractions and make it 1 fraction. And how would you do that? Well, you need a common denominator, and after you have a common denominator, you can add the 2 numerators together. Now, how am I going to give it a common denominator? I'm just going to multiply both terms by the other's denominator, and all of a sudden x plus 5 times x plus 1 will be the common denominator. And what we'd have is x plus 1 plus negative x minus 5 over x plus 5 times x plus 1. And we can simplify that. This would just be negative 4 over x squared plus 6x plus 5, right? And that was the extent of where you would go in algebra. Well, we are going to try to take the antiderivative of that, okay? And we can't just by looking at it. But what we are going to do is take this process that you did in Algebra 2, and we're actually going to go backwards. We are going to take this fraction and decompose it into a sum of 2, what we call partial fractions. So what we can say is, hey, let's not take the antiderivative of this. Instead, why don't we take the antiderivative of these 2 fractions when added together, give us this fraction, and you should think to yourself, oh, well, that helps because I can take the antiderivative of these individual pieces, right? The antiderivative of 1 over x plus 5, since it's x to the first power, is just the natural log of the absolute value of x plus 5. And the antiderivative of negative 1 over x plus 1 would be, this is just a constant, so you can just leave it out in front, negative 1 times the natural log of x plus 1. Turns out this here is the antiderivative of this. Now the key though to today is we need to figure out how we go from here to here, okay? And that's going to be the process. Before we go into that process, let's recall a couple rules about simplifying logs. So this is just like a little box in the corner. If you have a constant in front of a log, you can move that constant up and make it the log of x to the c power. Okay, do we remember that? Do we know why that works? Mostly teachers just tell you stuff. They don't tell you exactly why. Logs are the inverses of exponentials. So we're talking about exponentials, e to a power, powers. Well, if you look at powers, if all of a sudden I have e to the A times B, right? A product, C times log X, A times B. Well, we know we can rewrite this as E to the A to the B. So all of a sudden I can kind of take the B up, or I can take the A and move it up and write it as E to the B to the A. So that's why this rule works with logs and why you could do that, because it goes back to properties of exponents. Okay, so that's one rule you need to know. Another rule is if you have two logs being added together. Anybody remember what that's equivalent to? Yes, the log of the product. Why is that true? Well, let's remember if I have, say, E to the A plus B. How can I rewrite that? E to the A times E to the B. It's kind of the same lines as this. And it is a rule, however, you don't have to kind of know it. If you're subtracting, you end up dividing the two guys. Why is that? Well, this is like a -1 that could be raised to the power. You can rewrite this as log x times y to the negative first, and that's the same as log of x over y. Okay, so if you're subtracting, you divide. So those are all things that you learned in Algebra 2 that you didn't know why, and you forgot. Okay, so that means if I have something like this, I could simplify it. This is log of x plus 5 minus the log of x plus 1. Or you can move this one up, and it's log of x plus 5 times x plus 1 to the negative first. Either way, when you simplify it, you'll have the log of x plus 5 divided by x plus 1. And if we have a multiple choice question, we will have to simplify our antiderivatives to potentially get the right answer. Okay, so we would expect an answer like this simplified. Okay, so that's the idea. The idea is take this, turn it into these. I can take the antiderivatives of those. Don't forget your log rules, but here's the key. How are we going to do this? I'll show you. So this is called partial fraction decomposition for antiderivatives. We're going to rewrite a fraction as a sum of multiple fractions. That we can antiderive. Derive. Look, my R's and my V's look very similar. All right, here we go. Step 1. We have to understand the factors of our original fraction, okay? So in the previous guy, if we started with x plus 5 times x plus 1, we ended up with x squared plus 6x plus 5. So we need to be able to understand what the factors of our guy that we want to decompose first. So that's step 1. Factor the denominator of your fraction. So this is 4 over x plus 5 times x plus 1. Okay, we're going to set that equal to the sum of two fractions with the two factors in the denominator. One for each partial fraction. So I got an x plus 5 in the denominator of 1. I got an x plus 1 in the denominator of the other. Okay? Here's the key, though. We don't know what goes here. We don't know what's here, what's here. Okay? So we will actually place a variable like a capital A or a capital B there, because we're going to have to find out what that is. We're not going to guess and check. We can actually just set up an equation that we can solve. So factor the denominator set equal to the sum of fractions with the factors unknown numerators. Okay. We're going to solve for A and B. How are we going to do that? Well, easiest thing is to get everything onto the same level. So get the denominators out of every guy. The way we can remove the denominators from all of ours is to just multiply each term by x plus 5 times x minus 1. X plus 1. So I'm going to multiply this, and I'll multiply this entire right side by x plus 5 times x plus 1. But when I multiply the entire right side, I'll be multiplying each individual term by this. Okay, now watch what happens. The x plus 5, x plus 1s cancel over here. They're gone. Here, the x plus 5s will cancel, leaving me with just a times x plus 1. Here, the x plus 1s will cancel, leaving me with b times x plus 5. Your initial reaction is to distribute things. Do not distribute things. It will not help you. Okay, but what we have is an equation with some x's, a's, and b's. Now, this is an equation. It must be true for all x's, which means we can pick certain x's, strategic x's, that we will be able to use to eliminate things and help us solve for a and b. Okay, so I will say the next step is to pick strategic x's to help find a and b. What would be the strategic x's that I could use that would help me solve for a and b? Exactly. Good. If you're thinking -1, -5, you are correct. Because when I plug in -1, what happens? A goes away. It'd be a times 0. Gone. I'll write it down just so that you know. A times 0. And then it would be b times +4. Well, I've just found b. b is +1. The other one would be -5, another strategic x. Well, I'd have 4 on the left side. If this had x's in it, I'd be plugging in -5 into that. Sometimes it will. Sometimes it'll just be a constant. Here it's just a constant, so we have 4 is equal to, I plug in -5, I'd have -4 times a. And then over here it'd be b times 0. So b goes away, leaving you with a is equal to -1. We have just gone backwards and we've decomposed a fraction. I don't think you guys learned this in algebra or pre-calculus. Possibly. Did you? Yeah, did you do it ever? Maybe? All right, good. Well, it's a technique used here to find antiderivatives. Okay, so that means if I wanted to take the antiderivative of the first guy, 6x plus 5. Really, I just need to take the antiderivative of -1 over x plus 5, and I add it to the antiderivative of 1 over x plus 1. This is negative log absolute x plus 5. This is positive log x plus 1. Add a c, and you got it. If it's a free response question, you can leave your answer like that. If it's a multiple choice, you might have to simplify this to be log of x plus 1 divided by x plus 5. Plus a c. Okay? How did I get x plus 1 over x plus 5? Well, either you rewrite this as log of x plus 1 minus x plus 5. So you just move this to be in front of this, and then you can see, oh, I'm subtracting so I can divide. Or this -1 is a power. You can write this as x plus 5th to the -1st. You multiply x plus 5th to the -1st by x plus 1, and then to the -1st is just in the denominator to the first power. Okay? That's it. That's the process. Decomposing a fraction to help you take an antiderivative. Why don't you guys try a multiple choice question from a BC test? Now, if you see a question like this, and you're taking the BC test, the first thing you should be thinking is, can I factor the denominator? If you can factor the denominator, you're thinking partial fractions. I'm going to split this up. So factor the denominator completely. That'll be equal to a sum of two fractions with both factors as their denominators. Well, each individual factor has a denominator. Multiply everything by the factored denominator so that you get everything all up at the top. So I multiply by x plus 2, x minus 2, x plus 2, x minus 2, x plus 2, x minus 2. You'd end up with 8 after things cancel. A, x minus 2. And b, x plus 2. Pick strategic x's so that you can cancel a and b and solve for the other. So I'd pick a strategic 2 to get rid of a. I pick negative 2. That'll get rid of b. Again, a is negative 2, b is 2. So I'll end up taking the antiderivative of negative 2 over x plus 2 plus 2 over x minus 2. Either individually or separately, whatever. This negative 2 log x plus 2. This 2 log x minus 2. I look at my answers. I say I'm really close, but doesn't look right. However, I'm confident in my work, confident that this is correct. So it means it must be one of the other ones after I simplify. Go ahead and simplify and find the correct answer if you haven't done so already. Okay, I factor out a negative 2. Actually, I factor out a positive 2 because I see positive 2 out here. And I have negative log x plus 2 plus log x minus 2. Well, since I'm adding, I could multiply this together and have this to the negative first, or I could rewrite it so it's x plus 2 minus, or sorry, x minus 2 minus log of x plus 2, giving me 2 ln x minus 2 divided by x plus 2 plus a c. C is the correct one right there. Questions? Okay, not bad, right? Well, they get worse. Let's look at this guy. So I'd expect on the quiz that you're making, one question, like one of those first two that we did, one of those simple ones with just an A and B. Your second question would probably be something like this. Go ahead and factor the denominator completely. Let's see what we get. Completely factored, we'd have x plus 2, x minus 2. Let's get rid of that. All right, factor out the x, leaves me with x squared minus 4. Now I have x plus 2, and x minus 2. Guess what I need? I need an A. I need a B. And I need a C. Okay, so the decomposition of this fraction is decomposed into potentially 3 different fractions. Okay, now sometimes A, B, or C will be 0, so you won't need all 3 of them. It'll be easier than that. But sometimes they are actual numbers, A, B, and C are all different numbers. All right, let's see what we'll get. Multiply everything by x times x plus 2 times x minus 2. And notice the top is now not just a constant, it's something with x's. Okay, now I multiply it, and the x's would cancel. I'd be left with a times x plus 2, x minus 2. Here, the x plus 2's would cancel. I'd be left with x and x minus 2. Here, the x minus 2's would cancel. I'd be left with x and x plus 2. Now, you might think, oh man, A, B, and C, it makes it that much more complicated. It actually doesn't. We would just have 3 strategic x's, like 2, 0, and negative 2. And notice, if I plugged in 2, A would go away, B would go away. It would just leave me with C, which would be C times 2 times 4, which would be 8C. So ends up, our strategic x's will help us cancel 2 out of the 3 variables, and things would work out nicely, okay? So let's go ahead and get A first. I would use 0, because it would get rid of B and C. Now, I have to plug in 0 into the left side of the equation as well, giving me 12 is equal to A times 2 times negative 2, so that's negative 4A. And that gives me A. Okay, go ahead and find B and C. Look up on the board to find the answers. Negative 2 times negative 4 is positive 8. This is negative 8. Okay, A is -3, B is -1, C is 5. So this is -3. This is -1. This is 5. You can go ahead and take the antiderivative of all of those pieces to get -3 log absolute x plus -1 log absolute x plus 2 plus 5 log x minus 2 plus a c. Now, after you get the hang of simplification, you'll just be able to know that if you have a negative, you're going to be in the denominator. If you're a positive, you'll be in the numerator. Make sure you move all of those constants up into exponential forms. The simplified form would be log of absolute x minus 2 to the 5th in the numerator, x cubed in the denominator, and x plus 2 in the denominator. And that's x plus 2 to the first power, plus the c. That'd be like question 2, something like that. Any questions about that? All right, well, they get harder. Let's say we have a degree that is higher in the numerator than the denominator, like that. This would be like a problem number 3 on your quiz. Okay, well, we're going to have to divide. And we're going to see if we can simplify this by dividing. Now, recall long division. Let's say we want to divide (723) by 4. Okay, I can do it using long division. What do? Well, we try to get rid of each of the terms, right? So if this was 823, I'd put a 2 there, and boom, the 8 goes away. Here I can't, so I'm just going to try to remove as much as possible from it. 4 times 1 gives us 400. I can subtract the 723 from the 400 and get 323. Remember, we subtract. Then I would try to get rid of the 32 next. And that goes 8 times. That's nice. So that's 32. It'd be a remainder of 0. So I just have 3 left over. And I would have a 0 there. Okay? So we have a remainder. The remainder is 3. Well, you can write 723 over 4 as the 180 plus the remainder divided by 4. So 180 and 3/4 gives us 723 divided by 4, right? So I took this, I divided it by that, and I can add it to what I have. The same goes for dividing polynomials. Let's go ahead and divide x squared plus x minus 2 by 2x cubed plus x squared minus 7x plus x. All right, what do? Well, we're going to try to get rid of each of the terms. We try to get rid of each of the terms by multiplying this guy by something so that I can remove the term. Similar to how we're doing it with the numbers. Okay, well, to get rid of 2x cubed, I need to multiply x squared plus x minus 2 by 2x. And we would multiply these two together to get 2x cubed plus 2x squared minus 4x. And just like before, we would subtract. Good old long division. Now, I don't like to subtract polynomials. I like to add the opposites. So I'm going to plus a negative and plus a positive, depending on what I have. Okay, this helps me not make mistakes. This leaves me with negative 1x squared plus negative 3x's, and I'll bring down the positive 7. Okay, well now I got to get rid of the negative 1x squared. I'm going to have to multiply this by negative 1. When I do that, I'll have another negative 1x squared. This will be negative 1x. And this will be positive 2. And again, I will subtract these two polynomials. Do not like this red line. And again, I do not like to subtract. I like to add the opposite. So plus a positive, plus a negative. Giving me negative 2x plus 5. Well, I can't get rid of the negative 2x because I have an x squared. This is going to be my remainder. Now, let's go back to the long division using numbers. I add the 180 plus the 3 over the 4. Okay, 180 and 3/4 is 723 divided by 4. This is the same thing. This would be equal to the 2x minus 1 plus my remainder divided by what I'm dividing by. Okay? Does that help me? Well, yes. I can take the antiderivative of 2x minus 1. And guess what I get to do? I get to decompose this because I can factor this denominator, and then after I decompose it, I'll be able to take the antiderivative of that. Then once I be able to take the antiderivative of that, I'll have the antiderivative of this entire thing, the 2x minus the 1 and that. So let's go ahead and decompose that. Okay, I'm going to take the antiderivative of this. I'm going to rewrite this as negative 2x plus 5 over x plus 2, x minus 1. Go ahead and decompose that. It's good practice. Figure out what A and B is. Multiply everything by x plus 2 times x minus 1. Pick strategic x's. You should get -3 for A. You should get 1 for B. Now we're ready to take the antiderivative of this entire thing, which is the 2x to 1, and then instead of the -2x plus 5 over the x squared plus x minus 2, we have, replacing this, these, and I can take the antiderivative of all of these individual pieces. What would the antiderivative be? I'll go ahead and just get rid of this, throw this away. X squared minus x minus 3 ln absolute x plus 2 plus ln absolute x minus 1 plus a c. Okay? Now, remember, if you factor and you end up with something like 2x minus 1 or 4x plus 2, how does that change your antiderivative besides having 4x here and 2x here? Is this correct? No. If this was a 4x plus 2, what do I need as well here? A 1/4, right? You have to multiply by the reciprocal of the coefficient of x. So this would end up being -3/4, and this would be 1/2, okay? So if you do a problem and your factors end up being like 2x plus 1 times x minus 3 or something like that, when you take the antiderivative, don't forget the reciprocal of the coefficient of x, okay? But our examples here, they don't see that. Now, they do get harder from there. That's pretty involved for sure. I'm just going to show you what you would have to see if you looked at some of the problems on the book and you were confused. So I can't tell you exactly why you need it. It's just you're going to need this if you have a problem that looks like this. An example, if I had factors that were like x and x squared or x cubed or something minus, let's say, plus 2, turns out you would need an a over an x, but instead of just a b over the x squared plus 2, you actually need a bx plus c. And then all of a sudden, finding b and finding c is a little bit more difficult. In this situation, you have to use i's because you'd have x squared plus 2 and you need to get rid of a. So that's why we're not going to do a problem like that. But just for the future, if you see something like this, or if you're looking at the odds as examples and you're like, why are they doing that? Because of this. You'll just end up with that. And if you have a factor to a power, let's say this one ends up being x squared times x minus 2. You not only need x squared, but you need just x to the first power. If this happened to be like x minus 2 cubed, you would need a d over x minus 2 squared and an e over x minus 2 cubed. Okay? We're not going to have to worry about that. So just if you see something like that and you're wondering, why do they have an x and an x squared? You just need it to be able to decompose this. Sometimes, like, this would end up being 0, and this would be a number. But just FYI, that's how you would do those. So let's review. We have, for your quiz that you're going to create, a simple one, like one of these guys, or that first multiple choice you did. One with an A, B, and a C, so maybe 3 factors. One where you have to divide. And the last one, just to help you out, probably should be like an area one. Let's look at this problem. Find the area from 0 to 1 under 5x plus 8 over x squared plus 3x plus 2. If you took the BC test, maybe you knew what you were doing. Maybe you just guessed when you saw this problem. If you were to guess, what would you guess? Everybody pick a letter and then do the problem. Divergent means the area is not contained. The area is infinity. Do we think it's E? Never E. Never E. Unless it is once. There probably is one E where like the answer is does not exist or divergent. Probably every test. But if you want to guess, I wouldn't guess E ever. Now we're trying to find the area, so it's not just finding the antiderivative, it's finding the change in the antiderivative between 0 and 1. So you decompose correctly, you find the antiderivative correctly, well now you have to find the change in that antiderivative to find the area. Now you can either simplify this first, or you can plug in values and simplify later. It's up to you. Make sure you're plugging in the values correctly. Be 2 log 3 if you do not simplify until the end. Don't use a calculator. Plus 3 log 2 minus the quantity of 2 log 2 minus 3 log 1. We should know that the log of 1 is just 0. Now this is actually easy. 2 log 3 plus 3 log 2 minus 2 log 2. 3 log 2s minus 2 log 2s, I just have 1 log 2. So I have 2 log 3s plus 1 log 2 Do log 3, that's log 3 squared plus log 2. Yep, that's log of 9 plus the log of 2. This is the same as the log of 9 times 2, which is the log of 18. Who guessed C? All right. C. C. Yep.
I got to the third to last step and I didn't know what to do. So frustrating because I wasted so much time on it.
I know this problem takes a long time to do. It wasn't on the actual AP test, but I'm sure there's something similar to it on the actual AP test. It was on the practice AP test. There's the practice test, for sure. Okay, so that would be the last problem that you would put on your quiz. 4 problems. Easy one, a complicated one because it's A, B, and C, one where you have to divide, and then one where it's the area. Okay, that's it. Go to work.